In this video, I'd like to talk about factoring monomials. And remember, a monomial is just a one-term expression. And for these example problems, we need to factor these monomials. So in other words, we need to change them into a product of potentially several different factors. And this can be useful for many different reasons or different applications, which we'll look at in later videos. So for this video, we just want to practice the idea of factoring. And with this first example problem, we need to find the missing factor g that makes this inequality true. And we could just solve this equation. We could just solve for g, or we can look at it in a slightly different way. We can start with our 18y to the third, and we're going to factor out this 2y squared. Or you can look at it that we're factoring out g. So either way works. And when you factor something out, you're essentially taking your starting term and you're dividing it by that factor. So we are factoring out the 2y squared, and we need to ask ourselves what would be left. So if we factor out a 2 from 18, we're essentially dividing 18 by 2. So we're definitely going to have a 9 left. And then we're starting with y to the third, and we're factoring out y squared. So we have 3 y's multiplied together, and we're pulling out 2 of those y's. So in the end, we would just have y to the first, or one of those y's left over. And you can check this by just remultiplying. Since we know 2 times 9, that's 18. And remember, y squared is just y times y. So we have 2 y's multiplied together here, and we're multiplying it by a third one here. And so when you multiply y 3 different times, we can just rewrite that as y to the third power. So it looks like in this case, we factored out this 2y squared, and we were left with 9y, or 9 times y. So g in this case is just 9 times y. And let's look at another example problem, just so that we can get the main strategy for how to factor these monomials. And this is going to be using an area model. So it gives us a more physical interpretation of what we're trying to do here. Now, the rectangle below has an area of 144 times x to the fourth square meters and a width of 12x meters. So we need to determine what the length of this rectangle is. Since remember, the area of a rectangle is just the length of the rectangle multiplied by the width. And for this problem, we're told the area is 144 multiplied by x to the fourth. And we don't know what the length is. I'll just call the length L. So we have L multiplied by the width, and we are told that the width, W, is equal to 12x. So we need to figure out what this length is, and we could just solve for L here. Or we can use factoring. So either way you want to approach it. And to solve this equation for L, let's divide each side by 12. So 144 divided by 12, and 12 divided by 12. So on the left, 144 over 12, that just simplifies to 12. So we have 12x to the fourth is L multiplied by 1 times x, since 12 over 12 is 1. And since we want to get L by itself, let's divide each side by x. So x to the fourth divided by x, we're going to be able to cancel one of those x's out. Since if we wrote this out, x to the fourth is really just x multiplied 4 different times. And we're dividing that by x. So x divided by x, we know is just 1. So like I said, one of those will cancel out, and we just get x to the third power since we have 3 x's multiplied together. And on the right-hand side, we have x divided by x. Those are going to cancel each other. And so we get 12x to the third is equal to L. So that should be our answer, but let's just double check. If we actually multiply those together, the length times the width, we should get 144x to the fourth. So if we take 12x and we multiply it by 12x to the third, that is our width multiplied by our length, we should get our area, which is 144 multiplied by x to the fourth. And we know 12 times 12, that's 144. And x times x to the third is x to the fourth. Since remember the exponent rules, if they have the same base, then we can just add the exponents. 1 plus 3 is 4. Or you just think it through. We have 1x here, and it's multiplied by 3 x's here. So in total, we have 4 x's multiplied together. But since we found the answer we expected when we checked it, we know for sure that this is the correct answer.